Hello and welcome to another Eagle class from Null Space Labs. The first thing I'm going to do is, in this class, is I'm going to convert our little logic analyzer board, which is here. I'm going to bring it up and expand it out here. Oops, about the right size. So this is just a little Cypress FX2 USB chip that can read a bunch of different signals and send them over USB 2.0 pretty quickly. So it works as a logic analyzer. It also works as a signal generator and a bunch of other stuff. It's a really useful little chip. It's got an embedded 8051 in it, and it runs pretty well, just with a few basic components. You got a voltage regulator on there, some decoupling, a small serial EEPROM, and then the rest of it is just like circuits for reset and stuff like that, and a power LED and a couple of headers. So the first thing I'm going to do is I'm going to save this as a different project because I want to keep the existing one. So what I'm going to do is make a new folder, NSL and logic BGA. Save it in there and change the name of it to the null analyzer BGA. It's actually VF BGA, but that's fine. And one of the nice things that Eagle does is it actually does the same for the schematic as well. So when you save it, if you note up here, it changed the name as well. So bring that down so you can see it. So it changes the name for the schematic and saves it as well. So those are both saved now. So now I'm going to go flip back here. I'm going to rip up all the existing signals, and then I'm going to change this package. So I'm going to use the technology command, and then I'm going to go over here, and I already created a BGA here, so it's VF BGA 56. So I use show all package to show different types of package, not just the ones in the same family. And hit OK, and now it's changed. So there it is. Crazy little BGA. It's very small. This logic analyzer is pretty small as it is, but the VFPGA is even smaller. It's going to be very interesting to do in Eagle. So the next thing to do is I want to use a 4-layer board. It might be possible to do it as a 2-layer board, but it'd be very difficult. So in the DRC command, go to the layers, and we're going to modify this to use 1, 2, 15 and 16. So those are fairly standard layers. Some people use 1, 2, 3 and 16. Some people use 1, 2, 5 and 16. Now the way that these stars work here, you can actually see it changing on the so you can notice this here will change as I modify these. So let's do that. So if we use a plus instead of an asterisk, now what that's done is hasn't connected those two layers together, and you can see where the green's been added. So what this does is do a full drill all the way through the board and connects all the layers together. So all the layers are plated together. So 1, 2, 15 and 16, if you do a via, they're all going to be connected. The reason we do this is because it's really cheap to get it manufactured. And the other way to do it is what's called blind and buried vias, and that means that you can go from layer 1 to 2, 2 to 15, 15 to 16 individually, rather than just every hole connecting every layer together. How that's super expensive. A lot of BGA does need blind and buried vias. It's just not really a way of getting around it, and we may even need it with this board. I haven't actually tried to do it yet, so we'll see how it goes. So that's the first step, is to change this. So we keep it up. 2 and 15 are our new layers, and let's do that. So the next thing I want to do is name those two layers. So we're going to use layer 2, and we're going to call that the ground layer. And Eagle knows that $ground sets that layer, so let's do that. And then the next thing I'm going to do is use layer 15, and we're going to call that one VCC. Okay, now good. So in the layer command, you'll see that we now have top, ground, VCC, and bottom. Okay, great. And one of the ways you can know that Eagle recognizes these as power planes is to go in here, and if you try to route on them, so if you try to change available and hit OK, it'll warn you and say you can't route a supply layer. So which makes sense because it's just a huge power plane. So we switch that to NA. We've got our bottom, we're going to do bottom the opposite way. So now we've got the ground and VCC. Okay, so now we're going to change the grid. The grid is really important in Eagle, especially so when working with very small pitch components like this. So the first thing I'm going to do is actually just change the color of the grid just to make it a little easier to see. So go into the settings and then to colors here, click on the lines. I'm going to use the green. It's going to be a little obnoxious probably, but there you go. So you can see the center of the chip, and it doesn't quite fit on there. So let's go into the grid command, and we're going to change to millimeters for this one, and 250. We know the pitch of the chip already, so I'm going to do it as a multiple of that. And then same thing here for the alt grid, which I'm going to change to half of the pitch, and there we go. Now you can see it's gotten a lot denser, and now the chip isn't centered. So let's center the chip. Right click properties, just shave off the end here, and then the chip moves. And now as you can see, the center of the chip is there, and every pad is dead on. And to allow us to give it a little bit of routing room and put the grid there, the alt grid is actually half of this, so it's very small. But when you look at other components, I mean, it's crazy just how small it is. So it even switches it off because it's so small. So that's the first thing to do. So now we've got all those pads on the grid, and if we use the AutoRouter or any other kind of hand routing, Eagle will be able to put them down there. Now we're going to check over the DRC and make sure that everything's set up. I'm going to pull up the web page of our PCB prototype house that we used, which is Silver Circuits, and here is their tech spec. So you can see the VIA 12 mils, which is quite big, but yep, there's not much you can do about that one. So let's take that away and go back into the DRC and take a look over it. So clearance is set 7 mil, that's what we want. Dimension, drill hole 8 mil. So the minimum drill is 14 now, so let's bring that down to 12. Minimum width 7, leave that there, and select that in. So now we've got the minimum drill size set. So the next thing we're going to do is, for a bit of a laugh, let's try the AutoRouter, see what it does. So we'll set the AutoRouter routing grid. It's pretty small, and then let's just let it go in any direction here. This is going to take a little while because it's a very small grid. We don't route 15 and 2 because those are power plane layers. So let's let it go and see what happens. I may just pause the video and restart it when it's finished, but you can see it's starting to figure it out. It's going to be kind of messy. But this is not what you're supposed to use an AutoRouter for, so it's not going to work, obviously. And we can see that some of the ground pads are actually, looks like they're having a bit of a problem, or the power pads are getting a bit of a problem to get to those pins. So let's see what's happening. I'll just pause the video and then come back when it's finished. Okay, and now the AutoRouter is finished. Yeah, that's what it managed to do. I mean, those holes are huge, so it's not going to, normally would fan out from here. It's not able to make some of the connections, and there's just a whole bunch missing. So the next thing I'm going to do is actually sit and think about this one and see how we're going to route it, and then I will continue the video later. Thanks.